It is incredible that they can produce gigantic gears in such a rudimentary workshop, which would typically require production lines worth millions. In industrially developed regions, such industrial gears require large advanced equipment and multiple complex manufacturing procedures. But here, adhering to the tradition of, if you can't buy it, make it yourself, and relying on exceptional skills, they can hand-cast gears using only melted scrap iron. Witnessing this process is genuinely astonishing. First, the master spreads a layer of molding sand in a large pit on the ground, then brings over a gigantic circular gear template as tall as a person. The template's pattern is placed face down in the center of the pit, and the shape is imprinted onto the molding sand by continuous tapping. After filling the surrounding gaps with molding sand, the template is removed, revealing a clear gear outline. This is just the first step in creating the casting mold for the gear. The template is put back in place after embedding steel pipes at the bottom of the molding sand to serve as the pouring channels. The master begins filling the gaps between the template and the pit with a large amount of molding sand, vibrating and compacting it until the sand is level with the height of the template. Detailed smoothing and trimming make the surface even more smooth and flat, and small holes are punched to act as vents during casting. The basic structure of the lower mold is now formed. Next, the masters bring over a sandbox and place it on top of the circular template to start making the upper cover of the mold. After tamping and compacting the sand in the sandbox, they skillfully and smoothly shape the suspension points without using tools and inject gas into the small holes to quickly solidify the molding sand. This completes the upper cover of the mold. The mold still lacks a vital structure, the teeth modules of the gear mold. Although the production of the teeth modules seems simple, it is exact. Fill the template with molding sand, compact it, and inject gas to solidify it. Once the sand block is removed, a teeth module is formed. After making the required number, they are attached piece by piece to the edge, forming a complete gear structure. The master expertly places them in position and ensures their distances are evenly measured. 6 similarly shaped sand blocks are placed in the inner grooves, and a cylindrical sand block is placed in the center. With this, the gear casting mold is fully completed. To make the mold structure more solid, the master needs to bake the mold using the residual heat from the molten iron bucket before pouring. After baking, the upper cover is placed on the mold, combining with the lower part to form a complete mold. Due to the large amount of molten iron needed for casting, the gaps at the joints are sealed with molding sand, and iron blocks are placed on top to increase the weight. Once everything is ready, the casting begins. After melting the scrap iron into molten iron, the master pours it into the mold. Just one bucket of molten iron makes a single gear, indicating its massive size. Once the pouring is complete and the molten iron has wholly cooled, workers remove the cover, use an iron chain to pull the entire gear and mold out of the pit, and clean off the hardened sand blocks from the high temperature. A gigantic gear then appears. This is only a rough piece. The raised suspension points need to be cut off, and the gear is sent to a lathe for fine processing, cutting the rough casting surface to become a qualified finished product. Although the gear structure is not complex, it is pretty time-consuming to process. With the master's patient handling, the gear surface treatment is completed and precise dimensions are achieved, making the gigantic gear from scrap iron fully complete. One cannot help but admire the master's exquisite craftsmanship and brilliant creativity. How would you rate this manufacturing method?